Time to configure us some SNAT. And I just like saying that. I don't know why. SNAT. I said Static NAT for so many years, and now I'm free to say SNAT just as often as I want. But much more importantly, why would we ever want to use Static NAT? Well, again, if a limited number of hosts need NAT, Static NAT might be the way to go. That's not really very real world, though. That's more theory, because usually when you're running NAT, you're going to have a lot of hosts that need it. But one other reason you might want to use Static NAT is that you have a server that has to use it, and you don't want to pull a routable address from a NAT pool in that situation because, spoiler alert, that's what dynamic NAT is. We're going to create a pool of addresses, and when a device needs a routable address, it pulls an address from the pool. So maybe we don't want to do that because, of course, the address would change from time to time, and you would want to know how to do static NAT. Now, this is just simply a one-to-one or one-on-one mapping of inside local to inside global addresses. And what we're going to do here is work with those two loopbacks I have here on router 1 at 10.112 and 10.122/32 respectively. And let's go ahead and we'll create in just a moment. We would need two mappings here for SNAT. But one thing that you've got to do, whether you're running static NAT or dynamic NAT or port address translation, you've got to put IPNAT inside and IPNAT outside on the appropriate interfaces, because you don't want to spend time troubleshooting your NAT mappings and then saying, hey, I forgot those. And they're really easy to forget, especially when you start working with NAT, because you're concentrating on these commands. And this one command is pretty long, so you get that in, you're like, why isn't this working? Always check IPNAT inside and IPNAT outside first when it comes to NAT troubleshooting. IPNAT inside goes on the interface or interfaces closest to the hosts that are having their addresses translated. IPNAT outside goes on the exit interface of the router performing NAT. So that's what we'll work with here. We're going to put IPNAT inside on our two loopbacks and IPNAT outside on the serial interface. Now, real world, you would really likely have a fast Ethernet interface here. We're using a couple of loopbacks because I want a couple of extra networks, and also to get you used to putting IPNAT inside on the loopback interface itself if that's what you're using. But typically you'll have a bunch of hosts off a fast Ethernet interface that need NAT, and you would just put IPNAT inside on the Ethernet interface or fast Ethernet if that were the case. So again, it's just a good rule of thumb before you even get started with identifying who's going to be able to use NAT and who's not and what kind of NAT you're going to use. Get your IPNAT inside and outside commands taken care of first. And you got a couple of other choices there. You don't need to enable it because that's NVI, that's for future studies. And what we're dealing with here is strictly IPNAT inside and outside. Let's try that again. There we go. So nothing wrong with having multiple inside interfaces with IPNAT inside. That's the other reason I'm using loopbacks here, because we tend to think when we start looking at NAT that it's one outside interface and one inside interfaces, but you may have multiple inside interfaces. Let's go out to our serial interface. And that's it. So now we can actually start on our static NAT config. And static NAT, there's one command. Because with dynamic NAT, what we end up doing is using an ACL, yes, those again, to identify the inside devices that can have their addresses translated, because you don't want just everybody in the network doing that. You might not need that. But with static NAT, the only command you're dealing with really is creating the static mapping. So let's use the IPNAT inside command. And source is where we're going with here, because we're not going to do any destination address translation. We're doing source address translation. And here's where the command differs, because you're going to use this in static NAT and dynamic NAT. And where it differs, hey, static specifies static local to global mapping. That's as explanatory as iOS help is ever going to get. When you are going to use dynamic NAT, you're going to call an access list to describe the local addresses, which means identify them. And we will be doing that very shortly, but I just want to show you the differences here. Keyboard's not cooperating. That's my story, and I'm going with it. Then you need to put your inside local IP address here. That's what we're doing. So that's going to be 10.112 in one case, and then inside global IP address. And see, that term is not bothering you. And That's it, because these are all for future studies, which I'm sure breaks your heart. But seriously, I've been in this business a long time as a field guy and an instructor, and there are options here I have not used with NAT. Typically, you're going to go with something as simple as the configuration we have here because it works so well. Geez, 10, 1, 1, 22. That's what happens when you change the numbers. 200, 1, 1, 2, assuming that's it. So we're assuming then that we were given the addresses 200, 111 and 200, 112. We mapped them to 2 and 22, and that's all there is to it. If you want to check your work, run show IP NAT translation, you can see here's where we got to know those terms, because we have the inside global and the inside local. They match up exactly as we had described. And really, for static NAT, that is it. And again, you could see where it could have limited specialized uses. Again, like if it had a server that you wanted to use NAT, but you did not want it to have a different IP address from time to time or a different translation, you might use static NAT. But you can also see what the drawbacks are, because the problem here is you got to have all these routable addresses to give out in the first place, whether you're using static or dynamic NAT. But the thing is, these hosts may not even be using these addresses right now. And the thing is, they're tied up. You can't give 200.111 to somebody else because it is statically mapped to 10.112, and that is the drawback of static NAT. So with that in mind, the issue is static anything. What's the problem? Scalability. And if you just have a few hosts, again, you might get away with it. But if you have 50 hosts, you don't want to be dealing with static NAT. You really don't. Dynamic NAT will be the NAT for you in that particular situation, because DNAT, or dynamic NAT, enables us to create a pool of inside global addresses. And those routable addresses are mapped to certain private addresses, the ones we identify as able to use the service, on an as-needed basis, and the mapping is dropped when the translation is no longer active. So it kind of sounds like DHCP, right? I mean, we're not statically assigning IP addresses. We're using DHCP to dynamically assign them when someone needs them, and then when that host doesn't need it anymore, eventually that address gets returned to the pool. Same thing here with dynamic NAT. We're going to create a pool of addresses, and as devices that we identify as able to use the service need an address, they can have it, and when they're not using it anymore, it's returned to the pool. So we will configure dynamic NAT coming up next.